Is that me recording this?
All right, I'm recording you right now. So get your notebooks out. Toes facing the wall behind me. Ready to take notes, okay? Now, I want to review where we've been. We've talked about Bernoulli trials, okay? And they have three requirements, okay? You have yes, no outcomes. Tyler, would you close the door, please? You got yes, no outcomes. The probability of success is constant. And trials are independent. Okay, now we talked about independence is usually an assumption. Okay, and we're going to talk about preconditions. We've talked about we're going to talk about some preconditions in a minute. Okay, now we talked about geometric probability, but we're much more interested in binomial. Okay, so in which you have n events with a p probability of success, and you're interested in x number of successes. Okay, so if we're talking about Vince Carter's free throw shooting, it's .78? Is that what you said?
Yeah.
Okay, so the probability of success is 0.78, okay? And let's say we're going to talk about he takes 15 free throws, so n equals 15, and we're going to say what's the probability that he makes. I want to lower the number of free throws we're going to talk about, and let's make it 10. Okay, and we're going to just talk about the various probabilities that are going to happen with this. Okay, so we talked about he can make 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10 out of those 10 free throws. So there's a probability of 0 and a probability of 1, 2, 3, and so on. And all these various probabilities all add up to 1. Probability makes 0 is quite low. The probability makes 10 isn't as low, but it's still pretty low. Okay, all these individual probabilities. And we said that the probability for any individual event, let me finish. Okay, so the probability of x successes is going to equal n, choose x, p to the x, q to the n minus x. So in the case of Vince Carter, the probability that he makes 7 free throws out of 10 would be 10 choose 7, 0.78 to the 7 times, 0.22 to the third. Okay? Everybody clear on that? I'll take questions later. All right? I want to get through this and I want to talk about a bunch of stuff here. Okay, so that's the probability he makes any particular free throw. And we can do that on the calculator. And so we can put in second and then vars and then arrow down to binom PDF. On my calculator, it's A. So we're just going to do this particular probability. I'm going to put in enter. And the syntax is NPX. So we would put in 10, comma, 0.78, comma, in this case, we're doing 7, close parenthesis, hit enter. And so the probability he makes exactly 7 is 22%.
I have a question about my calculator.
We'll take that later, okay?
Right. But it's just like whenever I pick binomial PDF, it's like something weird.
No, you just have a table to enter. You can choose the old-fashioned calculator presentation, or I'll do a pause and then I'll show you how to do it. Okay? All right. Now, so we can do a particular probability, but we're usually more interested in questions like this. What's the probability of at least 7 free throws? Okay, so if we go back to our table, that's 7, 8, 9, or 10 added together. Okay? Now, we have binom CDF which will do a accumulation of binomial probabilities, but it starts at 0. It always starts at 0. It can't be made to do anything else. All right? So if we want to do 7 through 10, we'll do 1 minus binom CDF, and we will subtract 1 through 6, okay, or 0 through 6. So we would, God bless you, we would do binom CDF 10, comma, 0.78, comma, 6. That would add up the probabilities of 0 through 6, subtract them from 1, and leave 7, 8, 9, and 10. Okay, and that would answer the question at least. In other words, that x is greater than or equal to 10. What's the probability that x, the number of successes, is not 10, I'm sorry, greater than or equal to 7? Okay? Now, it's a little bit easier if we're doing less than or equal to or whatever. What's the probability that x, the number of free throws that he makes, is less than or equal to 5? Well, in that case, we would simply do binom PDF from 0 to 5. Okay? So we would do, let's do it over here. So let's do this first one, at least 7. So I'm going to put in 1 minus, and then second vars, and I'm going to go to, I think it will be B, binom CDF, that's B on my calculator, and then I'm going to put in 10, comma, 0.78, comma, 6. Okay? Hit enter. So the probability that he makes at least 7 free throws is 1 minus the probability he makes 6, and that's 84%. Okay? Any questions? Did you get your calculator issue straightened out? Okay. Dulce? Hold on. Let me pause this first. Okay. All right. No. Let's hear your question. I'll include it in the thing.
How do you know when you're supposed to use binomial CDF or PDF?
Okay. The question is this is for E period. The question is, how do you know whether to use PDF or CDF? You use PDF when you want to find a particular probability. Okay? So we wanted to know the probability that he makes exactly 7 free throws. Then we use PDF. You will very, very rarely use PDF. You're usually much more interested in knowing what's the probability he makes at most or at least a certain number of free throws or a certain number of successes occur. Okay? Does that answer your question? Okay? Alex?
That was the same thing.
All right. Okay, now let's talk about the first precondition. Precondition number 1 in talking about Mr. Carter. Okay? We are dealing with a sample of 10 free throws. Okay? So the precondition number 1 is unless the population is infinite, unless population is infinite, like coin flips or throwing a die or something of that nature, then the sample must be less than or equal to 10% of the population. So when we're sampling Vince Carter's free throws, we got 10 of them. Okay, that's the same. In other words, N must be less than or equal to 10% of the population, where N is the size of the sample. Okay? So we're saying, okay, Vince Carter's lifetime percentage is 0.78. We only have 2 decimal places, but let's say it's 0.78, 75, 2, 3, you know. It could be because he's taking a lot of free throws.
Yeah.
Okay? Now, every free throw that he misses or makes changes his lifetime percentage, right? Slightly. Well, we don't care about those slight changes as long as the total size of n is less than 10% of his total free throws. And he's sure, did you get it? How many free throws had he taken? Do you know?
Yeah, he took 5,365.
Okay, great. So Mr. Carter, a great basketball player, has taken over 5,000 free throws. So we really don't, we could even take probably an entire season's free throws as a sample and still be okay. Certainly 10 is nowhere near 10% of 5,000, okay? So the precondition, this precondition is met. You must always, remember I told you must always state that we are assuming independence, okay? You must always write that out. You can't assume that the other person will assume that you're assuming independence. You just say, I'm assuming independence. You must always not just say n is less than 10% of the population. You must say 10 is less than or equal to 0.1 times 5,000. You got to put in the numbers if you know the size of the population. If you don't, let's say you're dealing with 100 people donating blood. Well, you know the population of the United States is over 300 million. Okay, so you use your common sense to answer that question, but you at least must throw in the size of your sample. Okay? You do not say this is not meeting the requirement of satisfying that precondition. All right? It will never satisfy the requirement for the precondition. Not when I assess you, and not on the test. Okay? Everybody clear on that? All right. So we can go through some practices and we'll do some homeworks and stuff, but this is the basic nuts and bolts of how you use this binom PDF in this context. Nate?
Is there ever like any time when you're doing this, like say for free throws, is there any time like where you have to amount to like other factors? Maybe like say his free throw percentage like in the final minute of the fourth quarter or something like that?
All right, so in case people didn't hear that in the E period, Nate's asking about other factors that affect the certainty of the .78. And Nate's correct, but this model is not equipped to handle anything on the level of, God bless you, on the level of human uncertainty. There's no doubt in my mind that certain players, like the guy who comes to mind especially is Michael Jordan. The guy was the most valuable player in the playoffs every time he was in the playoffs. That's not an accident. That's not a probability model. There's no explaining that. Okay, that has to do with factors that go way beyond the scope of a model like this. So, and other players don't seem to do as, you know what I mean? So, there's no way to answer your question. Your question requires a whole different kind of model for probability. That's outside the scope of this course. Okay? It's a great question. Okay? And a great source of debate in sports. By the way, can you guys believe this thing with Notre Dame? I mean, is that the weirdest thing you've ever heard in sports or what? You know, that is the strangest thing I have ever heard. Okay. We'll talk about it later. All right, let's keep going. We got to keep going. Okay. All right. Now, here is. Okay. We'll once I'm going to shut this thing off and then we'll talk about it. But we got to go on to the next topic, and that is just as we use discrete random variables with the normal model, we're going to use binary probability with the normal model. And the situation in which we do that is when n gets really big. Okay? So, the situation they're talking about in the book is kind of interesting and is actually, not a completely trivial or ridiculous circumstance. So let's talk about here, let's see, let me find the page with it. Okay, here's the deal. Actually, the discussion in here is a little bit obsolete because calculators have gotten a lot better. All right, but suppose you need 1,850 units of O negative blood. because you're drawing blood, O negative. Okay? And you're going to collect from 32,000 donors. Okay? So, N equals 32,000. Okay? And X, that is the number of successes that you are interested in. You want 1850. Now you want to know what's the probability that you're not going to reach your goal. That's the question here. Okay? Now, the probability of X, of success, is 0.06. Okay? 6% of the population, so that's P. So P equals 0.06, which Q equals 0.94. Now, if we're going to use this will actually work in your calculator. You can put this in your calculator and you will get the right answer. But let's use the normal model anyway, just so you can see how the normal model interacts with the binomial model. Now, if you're going to use the binomial model, you have an assumption and a precondition. Okay, the assumption is independence, and the precondition is that N is less than 10% of the population. If you're going to go one step further and use the normal model with the binomial probability model, then you have another precondition, precondition 2, which also must be established mathematically. Okay? And NP, in other words, the size of your sample times the probability of success must be greater than or equal to 10, and NQ must be greater than or equal to 10. So in this case, you would have to state 0.06 times 32,000, this is a little ridiculous, is greater than or equal to 10. You got to work that out and you got to show it. And then, now obviously, if 0.06 is greater times 32,000 is greater than, it's not hard to see that 0.94 times 32,000 is way bigger than 10. Okay? But both NP and NQ must be greater than or equal to 10. And as a precondition, this must be stated mathematically with the specific numbers in your particular situation. Okay? So, as I've written it out here. But you need to put it in your calculator and come up. What is 0.06 times 32,000?
1920.
1920. Thank you. So 1920 is clearly greater than or equal to 10. Okay? So you've satisfied, you've said, I'm assuming independence. You must say that. I assume trials are independent. And I have, 30, now, is N less than 10.1 times the population? Well, is 32,000 less than or equal to the population? What's the population of the United States? 300 million. Okay. Check. Okay, you're cool. All right, but you've got to state it. Don't say, well, any idiot, all right? That's not how it works, okay? You have my total sympathy, believe me. All right. So, we're going to use the normal model because we're saying, now, what is the mean and what is the standard deviation? The mu is going to equal N times P. In other words, 1920. Now, sigma equals the square root of NPQ, which is simply, sigma is going to equal the square root of 1920 times 0.94. And what is that? How do they work that out? Give it to me. 1,804.8? Square root. No, that's the variance. Well, that's fine. That's cool. You gave me the variance. Okay. You gave me the answer to a different question. 42.48. Thank you very much. Okay. So here's our model. In the middle goes NP, 1920. Now, what are we worried about? That we get less than 1850. So 1850 is going to go over here somewhere. Okay? Now we're concerned that we're going to get less than 1850, so we're shading to the left. Okay? And we want to know this area right here. Okay, now from here, it's, you know, back to the beginning of the course. Okay? Z equals y minus mu over sigma. So we're going to get the z-score, 1850 minus 1920 over 4248. That's the z-score. What is it? Can somebody work that out, please? So z equals, what does that equal? I got a calculator. Nate?
Negative 1.64.
I think that is the right answer. Negative 1.64. You can check that on the next page. That sounds right. Okay. We had any verification on that? Any corroboration, I should say. Okay, Dave, you got the same thing? Okay, great. All right. So here is negative 1.64. Okay. What are we doing now? We are going to say the probability that Z got, should have said God, let you got hiccups. I'm going to drink of water. Who's the one who's hiccuping? You're the one with all the water.
She won't drink her own water bottle.
You know what cures hiccups? Salt. A little bit of salt. If you lick a little bit of salt, it really, I'm telling you, it works. Okay. It's going to equal normal CDF. Now don't go doing binom CDF or something. We're normal CDF now. We're back with the normal curve. Okay? And it's going to be negative 99, comma, negative 1.64. Okay? Whatever that is. What is that? It's like, it's going to be about, how much?
0.05.
0.05. Yeah, right, 5%. Okay. So, which is approximately equal to 0.05. So, now you got to write your sentence. The probability that you get less than, what was the goal? 1850 O-neg donors is 0.05. Okay, it's all of this is on the next page, I believe, somewhere. Or it's on this page. Was it on that page? Yeah, 0.05. Okay. So, all right. So this is it for this chapter, and we're done. And this is it for Unit 4. Okay. So everything from this point on is just, we're going to do homework problems, and we're get our head around getting our chops down about how to do this stuff and everything. Don't say what's your question.
What is something?
Okay. Here's what I wrote. The probability that you get less than 1,850 O-neg donors is 0.05. Because the whole question was, starting out was, we're gonna get 32,000 donors. We must get 1,850 units of O-negative blood. So we're worried, what's the probability we're going to miss that goal? Well, the goal is 5% probability. It's not like out of the, And so from there, we set up the mean and standard deviation of this binomial distribution, which is, the mean is NP, and the standard deviation is square root of NPQ. And then we use the normal model. Now, we could also use the calculator to find this. Let's use the calculator to answer this question. So, here's how I would do it. We'll do second, and then vars. I don't know, maybe when this book was written, the calculator couldn't do this. So we'll do binom CDF. Now, N is 32,000 to 3. Okay, P is 0.06. And I guess we'll do 1849. 1849. Okay? And we got pretty close to 5, but it's not exactly the same number. Okay, it's a little bit less than 5%. Okay? So it does work. Did you calculators do this? Did you get the answer right away? They didn't sit there they're not sitting there in Never Never Land? Okay. All right, fine. All right, so anyway, that's it, and I'm going to cut off this lecture here. Any other questions about what we just did? Okay, Alex?
If you scroll all the way up a little bit.
Where to?
So like there's like a 3, up a little bit more. What is it? 3 and greater than 1 times, what's that part?
This here?
On the 3, yeah.
Okay.
Right under the point 94.
All right. Okay, n, I don't know what the, okay, this is the third thing. Okay. No, I don't know what that, I don't know why that 3 is there, I forgot. Okay, but n must be less than or equal to 0.1 times the population.
Okay.
Okay? All right. Okay, I'm going to stop.